Okay, let's continue with the next type of reaction, which we know as elimination. So elimination, like we understand, is pembuangan. So we are going to remove a group of atoms from the carbons to form a multiple bond. Okay, a multiple bond. So means that the product is unsaturated compound, while the reactant in general is saturated compound. Okay, and then they will remove a small molecule, which in this example is the H2O. So remove from the carbon, this carbon, remove H, and from this carbon we remove the OH. Both these combined will form H2O. The last type of reaction is known as rearrangement, susun semula. So in general, the type of bond, for example, double bond, will still maintain. And then number of carbon also maintain. Here have 4, and then here also have 4 carbon. Number of hydrogen, 3 plus 2, 5. 6, 7, 8, 3, 4, 5, 6, 7, 8, 8 hydrogen. Okay, even for another example given here, also the similar. We have 1 double bond, and then here also have 1 double bond. Only this time, for the reactant, the double bond is between carbon and carbon. But for the product, it's between carbon and oxygen. But in general, you can see there are 2 carbon, 4 hydrogen, and 1 oxygen for both compound. Okay, next we are going to discuss about the identify the type of reaction. So normally what I'm going to do, because we are still new here, and then we try to just like play the game, spot the difference. So from here I can see there is carbon-carbon double bond, and from here the structure becomes saturated CHBr, CH2Br. So I understand that this one here, Br and Br are added, so I understand this is addition. Okay, then the next one we will look for the carbon-carbon double bond. So that means this is electrophilic addition. Okay, for the question number 2, I can see from here the reactant is saturated compound, and then for the product there is double bond, which means unsaturated compound. So from saturated to unsaturated compound, in general it is elimination. So for elimination, basically we didn't classify whether it is electrophilic, nucleophilic, or free radical substitution. Free radical elimination. Okay, then now we continue with the third reaction. From here I can see CH3 is the same, CH2OH, CH2Cl. So I can see the difference now. The OH replaced by the Cl. So we understand OH always is partially negative. Always, when we mention the charge for OH, we always say OH minus. For the Cl also, we always say Cl minus. So this one means OH replaced by Cl. So I understand the type of reaction is substitution. But what kind of substitution? Due to the OH is partially negative, Cl also partially negative. So this one is nucleophilic substitution. Continue with number 4, the reaction. So from here we can see CH3, CH3, CH2, CH2. So basically, roughly we have idea. Here is the part that is the difference. So from here, when we have the bracket here, we know that the bond, this carbon is C bonded to OH and then bonded to CH3, CH2, double bond CH2. Well, for this one will be CH3, CH2, C double bond O, CH3. So we can see both the double bonds still remain. So we can consider that the oxygens just rearrange, which bonded to H become bonded to C only. So this one we call it rearrangement. The last reaction, when you see the compound C6H6, basically you have to know it is a benzene ring with double single alternately. Okay, so and then C6H5 means that one of the hydrogen from 6 hydrogen become 5 hydrogen. So means that one of the hydrogen basically is replaced by the CH3. So for this type of reaction is substitution. Strongly reminder for everyone, it is not addition but is substitution. What type of substitution? CH3 if form ion always is a CH3 plus. In between carbon and hydrogen is partially positive. So this one is electrophilic. But because of this hydrogen is attached to the benzene ring, so we call this type of reaction is electrophilic aromatic substitution.